Hi, my name is Ben Wenger.
And I'm Francis David Nevill. Our senior project is Conveyor System Integration.
The objective of our project is to provide a way to operate the conveyor system in the Penn College Robotics Lab from a single workstation that is running a Microsoft Visual Studio 2008 application written using the C# programming language. In the center of the wiring cabinet is the Automation Direct DL06 PLC that we use to control most of the functions of the project. In the lower left corner is the Spartan 3 FPGA development board with a Digilant Net1 Ethernet module, which has been programmed to be an Ethernet to serial converter for communication to and from the TI RFID evaluation kit. The stepper motor drives and power supply are in the lower right corner. The Cognex camera breakout module is in the upper right corner.
This is the stepper motor driven pick-and-place robot. Here are the light sensors that trigger the robot and the camera. You can see the yellow Cognex checker vision camera and the LED light array that we constructed. We'll come back to that later.
As you can see, we have white and black topped plastic cans as well as metal cans. Underneath the lids of the plastic cans are RFID tags. The Cognex checker camera has been programmed to have 3 jobs, a separate job for each of the 3 colors of cans. The LED array was built to add the required lighting to the vision system. Consistent lighting is one of the most important aspects of machine vision.
The robot utilizes a suction cup to pick up the cans. A vacuum is created using an inline Venturi vacuum generator. We used inductive sensors as limit switches of the robot. They are triggered when metal is within the 8 mm sensing distance.
To the left of the pressure regulator are the electrically actuated pneumatic valves. Actuation of the valves controls the pneumatic swing gates and pin stops. Here is a good view of one of the swing gates.
The Spartan 3 FPGA and the PLC are both connected to the PC application using a wireless Ethernet router. The start-stop station contains an emergency stop, as well as buttons to start and stop the conveyor belt motors. The 3-position key switch is set up to start the conveyor belt and robot in automatic mode, with the white can job selected when turned clockwise, and the black can job selected when turned counterclockwise.
Upon startup, the robot resets. It automatically finds its minimum and maximum limits. It also resets its horizontal and vertical 0 positions. This must be done because we are using absolute positioning. When starting the robot in automatic mode from the PC, the white can job is selected by default.
Now we'll use the PC to select the black can job. The red flash from the camera confirms that the job has changed. After removing this one black can, we'll change the camera's job to metal can selection.
Notice that the swing gate will allow a metal can to pass if the robot is not ready to remove it. When the light sensor toggles from an off to on state, or if the reader detects a tag, the pin stop is enabled. If the reader does not detect the tag within 1.5 seconds, the pin stop is retracted by the PLC. This system may allow multiple metal cans to pass without actuating the pin stop if they are in succession, but it will always catch the tagged cans.
If a tag is detected, the reader will read the color and number of the can that has already been written to the tag. It will also write the time and date of the reading to the tag. The tag ID, the timestamp, and the can color and number are logged to an SQL database.